Hi, this is Daniel Ziegler, and I'm going to be demonstrating my Markov model baby name generator for CSC480. So I'm going to start off by giving a brief demo of the program. As you can see, it welcomes you and everything, and asks you what gender you want to generate. I'm going to go with male just for the sake of example. You with minimum length 3, max length 15, and you get to choose your order. I'm going to start with 2, so I'm going to generate maybe 10 names here. So you got a couple of unusual ones like Wheelix, Alisuf, Girasanzo. This is really fun to look at. You can get some pretty funny ones here. I'm going to go again using different options. So this time I'm going to go with male again, and this time I'm going to go with 3, 10, same options. But, well, 10's a bit different. But this time I'm going to use a third order model and still generate 10. So you can see they're a bit more coherent here. Things like Ethu and Jamian, Lewis's. Anyway, I'm going to stop there and give a brief rundown of the code. So I use one enum in here just to represent the gender. The name reader basically reads in all the names one at a time into an array of strings, 1,000 since I know the exact number, and it adds an underscore to the beginning and end of them just to keep track of where the beginning and end are. So that's all for that one. The name analyzer proceeds to populate a model with the names. Now this isn't the final model, but instead it's a hash. Well, here's what I'm doing. I'm storing the names and probabilities in a hash map, which maps strings to yet another hash map, which maps characters to floats. I'm using a float for purposes of types, and I'll get into that later. But I'm just using whole numbers here to count the number of times a character appears. Basically, the string is the pattern it's looking for, and the character is which character appears after it, and the float is how many times that character appears. You'll see later why I'm using a float. Anyway, it'll go through these and count them up, and it will also, if it's not there, it'll add it. If it is there, it'll increment it, and it'll also add a tilde character, which basically is incremented once for every additional character that is found. It is the total. So the Markov model class will take that, populate the model using the name analyzer, and what it'll do then is percentify them. Here's how that works. Basically, it gets the value of that total number. That's going to be the denominator I use, and basically for every other float there, it's going to get the value and divide it by that total. That way, I'll get a decimal number that's basically a percentage. Only it's between 0 and 1. It also, once that's done, it still keeps track of the names, but it trims the underscores off the end of them. Now, to generate a single name, here's what it does. It basically goes through, it starts with the current string, it randomly gets the next character using getNextChar here. Now what that does, it basically gets the percentage of each next character. Here's how it works. It has a cumulative percent, and what it does is basically the end result is something like from 0 to 1 it's this, from 1 to 10 it's this, etc. But what I do is for every single character in the hash map that maps the characters to the floats, which is the percentage, it'll get the value and add it to the cumulative percent, and then compare it to the random number it generated. If that doesn't work, it'll add the next percentage and so on until it gets there. If it goes through every single one, the final value will be 1.0, because that's the total sum, or at least close, because that's the total sum of all those floats. But each way along the way, it checks to see if it's still less than the cumulative percentage. That way, it'll basically still have it. While it's not entirely random, it basically divides the list into certain intervals by basically adding that number cumulatively. So here's so once it does, it basically goes through the whole thing. It creates the list until the character gets the underscore indicating the end of the name. And this other generate name function takes a min length and a max length, and also makes sure it's within those boundaries, and also checks to make sure that it's not in the list. Baby names basically will take the user input and let them run the program, and that's basically all of it. So that concludes my presentation for this application. You can read up more about it in the write-up. Thank you for watching.